let's come on to the new person. We have a new member of the team, all the way from sunny China, or not so sunny, I'm not sure. It's Rasaviharii. Welcome, Rasa.
Thank you. Thank you for having me.
It's great you're here again. Now, you have a very interesting story to tell. Have you actually spoken publicly about this before?
Yeah, I did one other interview about the moon landings before.
Right, you are. I'm sure the listeners and viewers of Apollo Detectives will be very interested to hear this. And it is your statement. So, with no further ado, I shall hand it over to you, Rasa. Take the floor.
Should I start with my story first before we go to the pictures?
Yeah, absolutely.
Okay. So I was studying astrophysics in America, and I graduated in 1999. And I was actually offered a job at NASA, but I turned them down, and I went to India to study medicine. So that's why I have an Indian sounding name. But anyway, then later I was in America. I was traveling back to America in 2001, and I happened to be in New York City when the 9/11 happened. And so then, but it was just very shortly thereafter, I saw that a funny thing happened on the way to the moon. And at first, I was a little bit skeptical. I was like, well, we need some solid proof, to go that far. But then what happened was I was traveling around America, and then I was going back to India, and I went to the JFK airport, and they had a full-size image of the man on the moon on the wall in the airport. And so when I saw that image, and I could see the change of a pixelation between the background mountains and the foreground, it was so obvious, so clearly convincing, that because you can't really see it on a computer screen, but if you take a super high resolution and you blow it up to life size, then you can clearly see the different pixelations between the mountains and the foreground. So then I was pretty much convinced at that point. And I've been researching it ever since 2001. And then what happened was the next year, I went back to America, and I was visiting my friend in California. I'm not going to mention her name, but her sister actually works for NASA. And so I was talking to her about the moon landings. I said, well, what do you think about these moon landing things? And she says, I'm also skeptical. And this is a NASA employee who is skeptical. And so I said, that's interesting. Why are you skeptical? And then she told me, she said, I read through these documents very carefully about this moon agreement. And she said, something in there triggered me. It was like kind of reading like, okay, if we actually send a man to the moon, then it's regarding like mining rights and all these things. And so that's what made her skeptical. Okay, so I've been reading through these moon landing agreements. I haven't found the quote she's actually talking about, but something made her skeptical. And this was a NASA employee. I'm not going to tell her name, but then later on, I came to China 5 years ago. Okay. And I'm actually working now. Now I'm working in this what Marcus likes to call the 0 point energy. So that's my field of work right now, and I'm actually working with the Chinese government and with the top, like what you'd call the MIT of China, the top universities, and I'm specializing in quantum physics, and so I know a lot of the people in the Chinese space mission, okay, and I've talked to them, and so they have I talked to them about the moon landings, and I said, and of course they said, of course it was fake, and they have a big map. They have the most detailed surface map of the moon, and so it's very clear, for them that what we see in the LRO photos of the landing site, that's not what's really there on the moon, So And so I talked to them about it. I said, well, what's the deal? Like, why don't? So they said what happened was there was the second space committee of the UN. You know, China became a member of the UN. You know, the UN space. What is it called? UN.
Space Treaty?
UNOOSA. UNOOSA is the space organization of the UN. China became a member in 1980. And so the first they've had 3 conferences, the UN Space Conference. And the first one happened back in the 60s, but the second one happened in 1982. And that's by that time China was already a member. And so they kind of accepted them into the thing, and China had been doing a lot of work with their own rockets and stuff. And finally, by the third UN conference happened in 1999, and China was already ready to really. They had been receiving a lot of help from the European space and from NASA and everybody, and then they were ready to launch their first Shenzhou 1, which is like an unmanned orbit. And so so this third UN conference happened in 1999. And they kind of pulled the China aside and said, look, we're going to help you with your space program as long as you agree not to expose the moon landing. So China agreed, you know, so that's their situation now, is they're getting a lot of help. You know, we're about to launch our first space station, you know. And so like, of course, there's members in the U.S. Congress who have banned China from the International Space Station, right? That happened in 2011, that they banned China from the U.S. The International Space Station. But there's members of the NASA, and there's especially members of the UN, the EU, the European Space Agency, who want to continue working with China, you know, despite of these American politicians. You know, so we're working very closely. In fact, there's two European astronauts training in China to go up with our next space shuttle. You know, so we're working very closely with them, but we've all agreed, you know, don't blow the whistle on NASA, and then we can continue working together. You know, so that's the agreement now. But they all know it's a hoax, right? And so I've talked to them about that. And there's mainstream documentaries here in China that talk about how they faked it and stuff. You know, so it's kind of a comment. So you can almost say that I'm like an insider here. I'm not officially, I'm not working for the Chinese space agency or NASA or anything like that. But I'm very good friends with them because we're all in the same university and we're all like working in the same government stuff. So, you know, and some of my work with the 0 point energy will be applied maybe in future space missions, you know. And I've even met people in the International Space Station, you know, because of my work is involved with some experiments they did up there on the space station.
That's extraordinary.
So that's kind of my story. That's my story. And, you know, so I think with that, is there any questions, or should I jump into my presentation?
I have one question.
There's quite a few here, yeah.
Going back to your photo that you saw, and you said there was like a difference between the pixelations. So just remind me what that. So was this at an airport? Did you say where did you see this?
Yeah, I was leaving the U.S. going back to India in the year 2001, just after 9/11.
Yeah. And
then they had in the JFK airport. I was going to fly back to India.
Yeah.
And when I was walking to my plane, they had the full size, like life size. You know, you can stand next to the man on the moon and you're the same size. And they had that on the wall at the JFK airport.
So was it the classic Neil Armstrong shot, or was it a different...
No. This was a later with the mountains in the background. I think Apollo 15 or 15.
And what year?
Very clearly.
What year did they say this was taken? This photo.
Oh, I don't know. I think it was either Apollo 14 or Apollo 15 photo. It was a very classic one of him standing there, and then the mountains in the background, and then you can see the line cutting, you know, where the forescreen and the back screen projection, you know, is very clear.
Yeah.
71 or 72, I think that might.
It's in your folder here, I think. Yeah.
Where I was going with this was basically, obviously back then they wouldn't have had Photoshop, because you mentioned pixels. So I was wondering whether this was to do with kind of like TV image capture in terms of pixels, or whether they would have airbrushed it, because obviously with the pixelation issue, they wouldn't have had Photoshop, so they wouldn't have been able to manipulate pixels in that way. So I was wondering if there was another way, another process where they would have manipulated it.
Well, supposedly, you know, they were using that front screen projection, so
Right.
you could tell the difference between the background and the foreground.
Yeah.
I don't know if pixels is the right word, but you could clearly see the layering, you know, in the
A contrast
grain.
difference.
So
Yeah.
it's blurred.
not the contrast, but the grains.
Yeah.
Right, yeah.
I'd like to ask Rasa about what you said. This is not moon related, but you mentioned 0-point energy tests in the Chinese space program, and you mentioned that these systems,
And on the ISS.
if they work, they'll be actually used in the space program. Is that what you said?
Yeah, we have built the first power station, a 10 megawatt power station, which is producing clean energy 24 hours a day.
Blimey. Is there any? Just wondering, are there any plans to expand it into other applications? I wouldn't mind having one of those in my house.
Yeah, I mean, right now we're just working on powering the Chinese power grid. You know, our goal right now is to stop burning coal as quickly as possible, and also we want to shut down all the nuclear power plants as soon as possible. So this is we're making steps in that direction. We have this new kind of, we call it quantum energy. You know, anytime you're breaking the Newtonian physics, because according to Newtonian classic mechanics, you can't get more energy out than what you put in. So if you actually are getting more out than in, it means there's some quantum phenomenon going on. And I was actually the one who wrote the quantum mathematics. When I arrived in China 5 years ago, they had this machine and they couldn't explain how it was working. So they came to me and I showed them the math. I said, this is how it's due to this quantum phenomenon that you're able to get more out than in. So that was 5 years ago. I showed them the math. And then 2 years ago, we completed our first power station, and it's been running now for 2 years. So now it's, you know, it's a matter of like scaling it down, and maybe we can get it into a smaller unit, and maybe, you know, aboard a space shuttle someday. I don't know, but
this is like a publicly acknowledged program. This is not like a classified defense project.
No, this is classified.
Oh, it is classified, right? I see.
Sure.
Yeah, I you know, I'm not allowed to like tell everything how we did it, but you know, it's there, like, you know, and they're not going to be watching YouTube anyway. So
You don't want to go on a bank on that.
Neil, just a aside, Neil, you could. When I mentioned Rasa's surname, you might want to edit that out. Just.
Oh, but his name would be in the credits.
Oh, right. Okay.
Probably bleep it if you wanted to and stuff.
Yeah.
Be clear, we're not talking about
I don't want to get you in
free
trouble, Rasa. That's the thing. Well, I don't want to get you in trouble.
It's no problem.
Okay.
Because they need me.
Yeah. So we won't be seeing you at the salt mine soon then. Okay. Should we carry anything else?
I just asked the question. But just be clear, we're not talking about free energy or anything like that, are we? We're just talking about this new type of discovered way of extracting it. Is that what you're saying?
No. This is what we call quantum energy. It means we are using a little bit of energy to drive this thing, and then the energy it produces is much more than what's going in. So we take out of the output, we take a little bit to run the input. So it's producing 10 megawatts 24 hours a day with no fuel. Rain, doesn't matter on the sun or the wind or anything. This is just a self-looping system.
Feedback loop.
Yeah.
Yeah, it's a feedback loop.
You know, that is free in the sense. I mean, regardless of the mechanism,
Sounds
it's
like
free.
proposing a perpetual motion machine or something.
Well, it's,
Maybe I'm hearing what you're saying, but that's what it's starting to sound like to me.
It's similar to. I mean, I know it's a different mechanism, but we had a big scandal over cold fusion. I'm sure you've heard of that, Raza, and I think the rest of you have as well. In 1989, someone repeated an experiment originally done in 1920, where it was where someone discovered the anomalous heat effect, and Stanley Pons and Martin Fleischmann, the two scientists, called it cold fusion. Well, there's a bit of a story behind that.
That actually happened at my university in America.
Blimey.
But yeah, I mean, we just call it the quantum energy because the only way to explain how you can get more out than in is due to this quantum, and that's my specialty. I've been writing so many papers, and so that's my job. You know, I'm writing papers all day about this quantum energy and all the experiments which are being done in other universities around the world.
I mean, Andy and Neil and I have a colleague called Andrew Johnson, who he discusses the moon landings as well, but he specializes in this particular field because he said basically when this cold fusion experiment was done, there was a massive government media disinformation campaign just to shut it down. So that
and they not only that, they banned, because I know they were in my university. So what happened was those scientists who built it, they banned them from getting access to the materials that they were once using.
Yeah.
Okay. Should we press some of your visuals?
Yeah. I'm ready.
Okay.
I'm ready.
So you got the the Van Allen radiation belt image here.
Okay. Well, this is the one point I want to talk about is that a lot of people talk about the Van Allen belt problem, right? But the Van Allen is just one of 4 problems. Okay. The first problem, of course, is getting through the Van Allen belt, and so you know. But if you look at my picture, you have the blue side and then the red side, right? So the red side is just the solar radiation, which is bouncing off the Van Allen belts, right? So that's the second problem, is the solar radiation, and especially on the missions where they landed on the quarter moon, that means they had to go directly through that. Okay, I have another picture which illustrates that. But I'm just saying, like, that red shield, that red bubble which surrounds the Earth, it is you don't want to fly through that, and unfortunately they were, and so that's a big no-no. And the third one is I have another picture about this deep space radiation, and so they're talking about this new kind of shielding. Okay, and so maybe we'll come to that later. Right, and then the fourth problem is the micrometeorite problem. Okay, so I think we'll go into those a little bit later. But if you can, I have the second picture.
Yeah.
Which comes after this.
Just gonna call that up now.
Okay. So the first image was what you would call a side view, and now this image is a top-down view. Okay.
Uh-huh.
So you can see the solar radiation coming, and it's going around the Van Allen belt. Okay, so I have 2 images here. The top image would be a new moon, right? The moon is on the other side of the Earth, right? And then the bottom image is what we would call a quarter moon, or a waxing crescent. So there's a blue line I drew between the Earth and the moon. And so that's the course which they took. Apollo 11, Apollo 12, you know, I have a list of all the ones and what angle, you know, because if you want to reach the moon at a certain time, you have to draw a line. Okay, when our ship gets there, the moon will be there, right? So we want to land on a quarter moon. So that's the course they have to take, which is right through that most dangerous radiation point. Okay, so that's a big no-no. And so the reason why that they wanted to land near the shadow when the moon is first coming into daylight, right? What do you call the terminator line?
Mm-hmm.
They always try to land as close as they can to the terminator line. Why? Because that's the coldest time. So the people in NASA, there's people in NASA who knew it was a hoax, and then there's the rest of the people who thought it was real, right? So the people who knew it was a hoax, their job was to make it believable to the rest, right? So that's why they had to land near the terminator line, because if you land farther away from the terminator line, when you step onto the moon's surface, your boots are just going to melt. Okay, so anybody would know that. So they know they have to land next to the terminator line. So I have another chart which shows, the terminator line and where they landed, what phase the moon was in. And from that, you can tell that the angle, the course that they took to reach the moon at that time.
Okay, so have we seen this one before? It's talking about the physics of space, this one, Rasta, your statement here.
Yeah. Okay, so this is very interesting. I've been looking into their proposals for a new kind of shielding, right? So there's three kind of shielding that they're proposing. One is one is electrostatic, one is electromagnetic, and one is what they call plasma shielding. And so when you read these articles, they're talking about, well, one of them will block out the highly charged negative particles, and one of them will block out the highly charged positive particles, and only the plasma one will actually block out both the positive and the negative. But then it's like when you look at the references, okay, so these are the references from that article. And so what it's saying is, just if you look at the dates of these, this is the authoritative papers written on space particles and space radiation. Okay, and you look at the dates. This is 2004 and 2012. Before these dates, they actually knew nothing about space radiation, because in these papers, they're talking about, okay, you have the highly charged positive particles coming from the sun. Okay, they knew a little bit about that in the Van Allen belt, but now they're discovering these highly negative charged particles, which are coming from not black holes, but like supernovas in other parts of the galaxy. So these papers of 2004, 2012 are the actual physics of how supernovas create these highly charged negative particles. And they don't even have, they don't have any kind of a shielding to protect from that. And they didn't even have the mathematics to find out what these things were before 2004. Okay.
Yeah, they wouldn't have made any materials. They wouldn't have even thought of any materials, unless lead.
Yeah, which is, well, yeah. And Megan Ewell instantly said that as far as the charged particles go, lead would just make things worse. She said it's one of that's. Yeah, she kind of disproves her own point, though, doesn't she? Because she said, "Oh,
what's the idea of that is depending on the Z of the material that you're using, Z meaning the atomic number, the higher the Z, the more secondary radiations you get because of the way the radiation actually interacts with the material. Like your electrons are going to produce X-rays as they're stopped or deflected by the material, and the protons are going to produce gamma rays, and of course the heavier particles, like alpha particles. And a lot of people don't realize this, but you see textbooks diagrams showing, okay, the alpha particles are blocked by paper, the beta particles are blocked by the aluminium and whatnot. Well, here's the thing. People assume, okay, if it's going to be blocked by paper, it'll be blocked by the aluminium as well. Well, no.
No,
If
because it
the, if
bounced
the
off the back.
conveyor belt hits the aluminium, I actually found this out firsthand when I was doing my physics lab sessions. Right, this is part of my astrophysics course. When if you have the same alpha emitter and you put the aluminium piece in front of it, what happens is you actually get a much higher Geiger counter reading than you did with the paper piece. And
As more is coming off, you get more material coming off the aluminium as it's being scattered out.
Yeah, exactly, because you're getting the secondaries. You know, it's smashing into the aluminium and it's being fragmented into all these secondary particles. Not to mention all these different particles that the aluminium itself is made of.
And I was actually joking because that is how anti-tank missiles work. By the way, they actually use that approach where they hit the outside of the tank and it's the actual material on the inside of the tank which actually kills everybody on the inside. And that's the reason why they like depleted uranium. For that,
You may have been joking, but that's literally the same effect. Obviously, it's a much smaller scale, but it's
no, I was
joking
about the lead.
Okay, so the amount of micrometeorites which hits the moon is 10,000 to 20,000 tons per year.
Whoa.
Okay. And the speed of a micrometeorite is 22,500 miles per hour. Okay. so now, like, what is the definition of a micrometeorite? Okay, yes, some of them are very tiny, like a grain of sand, but they can come in all different sizes, you know, to a big rock, you know. So like for example, we know that the Indian lander failed, the Israeli lander failed, probably because they were hit by micrometeorites. You know, I think anybody who actually lands on the moon, they're just getting lucky. You know, it's like Russian roulette. You could get hit by a micrometeorite anytime. You know, even the ISS was hit by that once. You know, the official story is that all these micrometeorites are very, very small. You know, and they say, okay, we've got some of our modern probes have a micrometeorite detectors, and so we can detect, you know, a hit and things like that. But again, you're just getting lucky that you're hit by a tiny one that's like a grain of sand. But if you get hit by a slightly larger one, which is going 22,000 miles per hour, you know, and then you look at the shielding. Okay, so this is the official LEM shielding, right? And so they're talking about, okay, we've got these layers, and they've got like 25 layers in the middle, and then you've got the main cabin there, and then you have that outer layer, and it's saying, oh, okay, we've designed it to stop the micrometeorite, right? It's totally ridiculous, you know. It's like that this tiny little, like, less than a quarter inch, you know, amount of shielding could have actually stopped a 22,000 mile per hour micrometeorite. It's just ridiculous.
You mentioned that you could easily put your finger through the walls of the LEM because the shielding was so flimsy. There is another case with the micrometeoroids that I think is worth mentioning, and that is the fact this actually happened with the Soviets. When the Soviets had their Mir station, they actually erected the hammer and sickle outside the space station. They put it up on the mast outside there, and shortly after they erected the flag, the Soviet Union collapsed. And of course, they couldn't, you know, make an unscheduled EVA to go get the flag, you know, take it down, put it up with the new one and stuff. But over the time, the flag got gradually destroyed by the micrometeoroids outside the space station. And when they finally went to retrieve it, there was only 2 threads left. And so now NASA is going to tell us that they have pictures from the LRO which shows the flag, the American flag on the moon, is still casting a shadow. You know, they had the little orbiter probes. They didn't just take pictures of the moon surface. They also had, you know, micrometeoroid detector packages, you know, to measure what kind of bombardment, what kind of damage we could expect, you know, from these from these kinds of meteoroids that you would expect to get on the moon. And you know, you can do the calculations. You know, you can look at here's the hit rate that we had for the Mir station. Here's the hit rate we have for the moon. And you do the calculations, and the flags would be destroyed in a few years. You know, there's no way they could still, you know, there's no way they could have pictures from the LRO, you know, taking pictures of the flag casting a shadow, which they claim to have done.
We've only got to see body
Yeah.
armor, like for bullets and things like that, you know, or armored vehicles, and you realise that you're dealing with something with, was it 22,000 miles per hour? I mean, that's many times the kinetic energy in terms of the speed and the size as you get from a bullet or a gun shell.
Let me say one more thing about the shielding and the micrometeorites. Okay, I spoke about this this radiation shielding, and they're talking about using this plasma shield to protect from both the positive and the negative. But what are they talking about when it comes to the micrometeorites? So the only way to really protect your ship from micrometeorites would be to make your ship out of diamond. Of course, you can't do that. So what the talk now, all the hype is graphene. They're talking about this multi-layered graphene, which would actually
C50 and C60.
Right. So the multi-layered graphene is, you know, that's the only possible hope of protecting from micrometeorites.
They spoke about graphene before, though. They brought that up in the 2000s when they first started talking about graphene. They started talking about how they could use that as a for exactly that, use it for shielding, multi-layering it. Because I remember doing it, polymerizing graphene.
Again, this is another. This is another problem that people were unaware of when the Apollo missions were being designed. Literally, it was at the start of the space age.
It worked right in Star Trek.
So they've been talking about the graphene idea for a while, but it's going to be extremely expensive to make an entire spaceship out of multi-layered graphene. Might as well make it out of diamond.
Yeah, because I remember seeing that one and the plasma one where they went to do a plasma field, created a film of plasma on the outside of the craft, but that one looks just as impossible, really. But that's your field. You'll be able to tell me more.
Yeah, so there's a lot of problems with the plasma shield thing. Okay, so this is just a little chart I made where I took the lunar phase image according to what day they landed, right? So then this chart is actually very helpful because it tells you like exactly what course they took. Okay, so like for example, if they want to reach the moon at a quarter moon, then they're heading like 45 degrees away from straight towards the sun, right? And if they want to reach the moon at a 90 degree, half of what do you call the first quarter? Sorry, half moon. I was just confusing. But then you'd have to take a 90-degree course, right, to meet the moon at that point. So like basically, you know, you have Apollo 15, Apollo 16, where they reached the moon at this, where it was halfway. And then you have Apollo 14 and 12, where they reached the moon, where it was in this gibbous phase. And then you have Apollo 11 and 17, where it was still in a crescent phase. So that tells you, it tells you several things. Okay, it tells you the course that they would take. And it also tells you what the Earth should look like from the moon, because the Earth will be just the opposite. So like if it's in a waxing crescent, then the Earth should be in a waning gibbous, right? Or if it's in a waxing gibbous, then the Earth should be in a waning crescent. So again, this is just an explanation, because a lot of people get confused about this. What should the Earth look like when you're standing on the moon? So it's just explaining, you know, if you're standing on the Earth and you see a crescent, waxing crescent, then you should see a waning gibbous if you're standing on the moon, right? And just the opposite. So this is just another. I help, you know, a lot of people in my group get confused about these things, so I just made these simple diagrams to explain it.
I've never heard the expression gibbous before. That's an interesting one.
Gibbous means more than half.
More than half, okay.
Can we just go back to that one, Rasa? So when you see the Earth rise with the Terminator horizontal, Is that correct?
Yeah, this is correct. Like I said,
Okay.
I have another image. Yeah, so this would tell you, so you can tell what your latitude is by the degree of the moon angle, right? So it would be the same thing for the Earth if you were standing on the moon, you know. So depending on what latitude of the moon they were supposedly standing on, that would adjust the degree of the Earth's angle there, terminator line angle. So I just made this to kind of explain. He was asking a question earlier about how the angle changes, what we would expect to see, you know. So that's why I made this little thing just to clarify. So you would, if you're standing on the equator of the Earth, you know, it's going to be horizontal.
Yeah, I see.
Because a lot of people in my group ask these questions like, well, what should the angle of the Earth be? And so from my examination of the pictures, they got that part right. You know, for most of them, they got at least the angle of the Earth right, because they could calculate, okay, we're at this latitude, so this is the angle of the Earth. So I think they did at least a good job on that. Okay, so this just comes from Apollo Lunar Surface Journal, okay? And this is from Apollo 10. And here it says, a starry night. When they took the photo of the Earth rise, you know, here it says it was a starry night, okay? So the reason I want to come back to that is, you know, I'm a very big fan of the American Moon movie, right? I'm always promoting it. But I only have one small problem with that, is that he blows off the star subject so quickly, you know? And I don't think the star question is so easy to just blow off, okay? And maybe here Marcus Allen can help on that. You know, I'm not a photographer, but when I was in high school, I took a course on photography and film developing, and one of my assignments was to take pictures of the stars, right? So I slowed my shutter speed down, you know, and I got a nice photo of the stars, and they were moving, you know, because my shutter speed was so slow. And so that's fine. Yes, we can make the excuse like, okay, look at how slow your shutter speed has to be. But you have to remember this. When you're in space, the stars are thousands of times brighter than they are here on Earth, okay? So you don't need to slow down your shutter speed so much to take pictures of stars in space. And you know, especially like the excuse about the moon glare. Oh, the moon glare would block out the stars. Yeah, but what about when your camera is like pointed up away from the surface? Or what about when you're in the cislunar orbit, when you're on the way to the moon? There's no Earth glare, there's no moon glare there, you know. So I think that it's not so easy to just blow off this star issue so much. You know, I don't know if Marcus wants to comment on that.
No, it's an excellent point you make there, because there is certainly considerable evidence to say that beyond the atmosphere, stars are very, very much brighter than they are on Earth, because they're filtered out by the atmosphere. There's a famous description given by one of the SR-71 pilots flying across the Pacific when he turned his cabin lights off, and the starlight was sufficiently bright for him to read his instruments by. Which indicates that way beyond the atmosphere, starlight is an impressive covering.
Yeah,
What's going on? Yeah, to actually photograph them. I mean, all the stories that are told when you've got the glare off the surface. Yeah, that's correct. You do. But if you point your camera just a little bit above the surface, you can then expose for the stars. But nobody did. No photograph exists showing that sort of level of stars, which you'd expect. It's one of the things that most people expected from the Apollo program, pictures of the stars, but none of it existed. I mean, there's the Apollo 16 infrared camera, which appears to show something, but it doesn't show them in any great detail. Oh, there we go. Oh, it's a very famous picture, that one.
Yeah.
Apollo 14.
Shadows going in all different directions. Yeah, local light source.
So So regarding this picture, there's one guy in Norway. His name is Reidar Finsrud, and he made this like a kind of like a perpetual motion thing where it goes around and around and around. And he's an artist, but also kind of a scientist guy. And he made an official. The Norwegian press came to interview him, and he did a show on the moon landing hoax in Norwegian. Okay, and so he used this image, and he created a scene in his house where he had a little model ship and the little rocks and everything, and he had the light, and he said this is where the light needs to be in order to create these images. It's a mainstream Norwegian documentary about the moon landing hoax.
Og det viser at lampa står rett til venstre for billedutsnittet. Og nå skal jeg gjøre det samme her, og så skal vi late som det er sola og flytte så langt tilbake som mulig.
Ja, nå retter de seg opp, ja. Nå går skyggene samme veien.
Alt nå? Ja. Kan du tenke deg hvor rette den blir hvis jeg flytter meg en million kilometer til venstre nå? Skjønner du at det er forskjell på en lampe og på sola?
Ja.
To say that is real life on the lunar surface is complete nonsense. The shadows don't fall that way in real sunlight. They fall that way in spotlights.
Bart Sabrell had made one video where he says, "This is the ultimate picture. If you can show how these shadows work, then I'll pay." I don't know what he said, but he said this is the ultimate. For me, this is like the ultimate picture. This is so clear proof, you know, of a close light source, right? It can't be any more clear than that, you know. And that's why that Norwegian guy used it also.
It makes me laugh that Mythbusters tried to prove that photograph was taken in direct sunlight and not in a studio by setting it up in a studio.
Give me a second. Should appear on your screens very shortly.
Ah, yes, this is the descent picture.
So, so again, this is just you can see like two people who are standing in the shadow of the lamb. And one is lit up like a Christmas tree, and one is all dark, you know. So that, you know, they say, oh, it's the surface glare which is filling him in, but then why is it not filling in the other guy?
Yeah, this is something Marcus has brought up quite a few times, and you can see very clearly also in both images, the background in the sunlight is quite well exposed. It's quite, it's got the same level of contrast. So that's is an anomaly. The only explanation I can think of is the picture on the right has a secondary light source, the one on the left doesn't.
So Rasa, you've got these other images here of the moon taken from one of the Apollo craft, allegedly.
Yeah, okay. So the last week I was taking a vacation, so I downloaded all of these thumbnail images, and so I scanned them all, and I have a list of like at least a dozen or so bloopers from these. So, but this is just one of them. So this one is Apollo 15, and that is the real 96. Okay. So when you look at the whole, what do you call, look at the big picture, you know, what you're seeing here, what they're supposed to be doing is this EVA, right? He stepped out of the capsule to retrieve the film or whatever. But and so that's supposed to be happening on the way back to Earth, right? But if you look at the images that are leading up to this EVA, they're actually getting closer to the moon. So this is just, like I said, I've got a list of like a dozen smoking guns that are like just discrepancies when you look at the bigger picture, like when you look at the whole roll and you follow it picture by picture and what's happening, you know, they're supposed to be heading away from the moon, but they're actually getting closer to it. You know, this is a pretty big mistake here.
Yeah, I was asking Rasa, can you hear me?
Yes.
Yeah, I was asking Rasa, this sequence of photographs you're shown getting away from the moon, what is the reference for that? Which film reel is it?
This is this is Apollo 15. the 96 reel,
Okay.
and that's 13087 to 13098. That I just took a quick clip of those, but if you look at the whole thing, you know, it's just ridiculous. I find so many mistakes like this.
Okay, so what are we looking at here, Rasa?
Okay, so this is from Apollo 16, and again, this is just a sequence of clips. Okay, and so what you're seeing is the LEM is above the command module, right? They had just separated. And then all of a sudden, the command module is many, many kilometers off into the distance. And then all of a sudden, the LEM catches back up with the command module. And again, now the LEM is below the command module. And then the next picture, the LEM is above the command module. So I can't figure out what's going on. This thing is just ridiculous. You know, I can't. It's just crazy. If you look at this sequence, like how the heck would they have filmed that? It's impossible. So I'll just give you the reference number. That's Apollo 16, roll number 113, and I'm looking at 18279 to 18294, and you can just see that the command module and the LEM are just dancing around. It's like, oh, come back, we need a better photo op or something. It's just ridiculous, this one.
Yeah, considering it's got very little fuel, it'd be a bit awkward to keep coming backwards and forwards. It would have to be a highly specialized rehearsed maneuvers, rather than waste time and stuff.
So this image was for Marcus Allen, because in one of the shows he said I don't know if it was the camera that was special or the film that was special. Okay, so here in this photo you can see the film canisters sitting there in the vacuum of space. Okay, so they're down in the lower left corner in the white bag. He got several film canisters sitting there. You know, so I don't know how those film canisters can be sitting there. You know, in that freezing cold vacuum. You know.
Well, that's assuming, of course, that they were in the freezing cold vacuum and they weren't at Cinder Lake in Arizona. It would certainly be true to say that a film exposed like that, because there's no pressurization around it, a film exposed like that on the lunar surface in the vacuum level that we know exists on the moon would be totally destroyed. So it's a complete nonsense that they even show an image like that. So either they're very sloppy on their information, or somebody is just trying to say, look, guys, you know, if you know what to look for, you'll see that the whole thing was fabricated.
Yeah. Also, I wanted to ask you, because you've had experience with Hasselblad before. So
Yeah.
maybe if you look at those, I mean, does it have that same kind of a canister when you pop in the film?
The film is in the magazine, which
Right, that
separate.
magazine.
Yeah, on the big magazine, you could have film that will hold up to 200 exposures. The small magazines, which they didn't use, they only used the big magazines, which had 150 to 200 exposures, and they can be separated from the camera and stored separately, so you can change it. But if you start changing the magazine on the lunar surface, you're going to have major problems, and not least with dust being kicked up, because we know there's a lot of dust around, assuming they're on the lunar surface in the first place, which I don't think they are. And those previous images of orbiting the moon and showing the command module and the service module separating and catching up, I think that was done on the big model of the moon that was held at Langley, Virginia. I mean, it was a very persuasive model because it was taken from the lunar orbiter photographs. They showed the real scenery on the moon because they'd been photographed quite comprehensively by the lunar orbiter. And before anybody says, well, they used film as well, which they did, it was all pressurized on the lunar orbiter. You could see these schematics of the construction of the lunar orbiter. The whole thing.
I actually have a video of one of my things I'm going to show you guys later. I actually have video footage. It's simulated, but it actually shows how the film was taken on the lunar orbiter and stuff. You can see how it's all the sealed chamber and the like and stuff. How they quickly scanned it all and transmitted it back to Earth.
I was going to say, not only that, would that be enough to shield it? Would those canisters be enough to shield them? Because they're just overexposed.
No, it certainly wouldn't be enough to shield it from the sort of level of vacuum you're experiencing on the lunar surface, assuming they were there in the first place. Because if you're going to pressurize something, you have to have it completely airtight, which on the lunar orbiter, it was. You can see the schematics. And on the Hexagon Spy satellite, you can see the same thing. It's a separate container containing all the photographic film. And it was that alerted me to the fact that the Apollo photographs could not have been taken on the lunar surface, not one of them, because the film would have been damaged in the vacuum that we know exists on the moon.
What were they using as film? What material?
Yeah, it was Kodak Ektachrome transparency material.
Okay.
Also Kodak Tri-X black and white film. So it was all photographic film.
Okay. Nothing special.
I think you could still get some of it, or maybe not anymore. Rather, I still remember seeing it for sale on Amazon a few years ago. It was the ISO 160 type.
It's still possible to get it today because Bob Williams did. He got some S-Star-based Ektachrome film. It's quite expensive because the development process is quite complex as well. And you can get the chemicals for that, which is what he did. He bought the film, he bought the chemicals to process it, by the book, and got it all correct. And the film was, at the very least, the color balance of the film was shot to pieces. And color balance was affected at the level of vacuum that we experience on the International Space Station today, torr 10 to the -6. When you get torr 10 to the -12 on the moon, it wouldn't just affect the color balance, it would affect the physical structure of the film itself.
Yeah.
Okay, now I did upload the buggy video, but unfortunately it's not accepting it into gallery there. But maybe you can talk about that, Rasa, and I'll edit in the footage over it later.
Okay, yeah. So this is one of the. I like to bring up points which aren't on the American Moon movie. So this is to me a pretty big smoking gun. Is like. When you look at it's called the famous rooster tail scene. It's when he's driving the buggy and all the dirt is splashing up behind him. That's why they call it the rooster tail. So, but then when you zoom in on the driver, you can see his arms is just sitting there stiff. So this is a mannequin. It's a mannequin attached to a remote control buggy. It's so very obvious that this is a mannequin, not a human being, because they wouldn't be able to keep their arm up, you know. So that's a really interesting clip.
It's an interesting thing because, like, when you're driving on a normal road anywhere, mostly obviously a tarmac road, you would be driving. You know, you'd have a certain amount of experience of driving and be confident to then drive with one arm on a steering wheel and maybe the other arm out the window. Now here they are on the moon, unknown terrain. Very difficult conditions, and it's not even a steering wheel, so it's like a joystick sort of thing. You would have thought that they may have held on to their seat a little bit, or maybe held on to the joystick or a kind of a dashboard or whatever, rather than just putting his arm out like that, wouldn't you? It does seem a bit of an odd one.
Yeah, very odd.
And I think the thrusters thing is something that you've pointed out, Jared, where you can see thrusts coming from certain spacecraft, more modern satellites or Soyuz craft, thrusting as they're docking with the International Space Station. You can see the thrusters, but on the Apollo craft, you can't see any thrusters at all, can you?
That's correct. The thrusters, they don't, in the Apollo footage, they don't seem to produce any visuals, any visual plumes, I should say. And you look at pictures of the Soyuz and even the space shuttle, and they're firing the thrusters. There's enormous white jets shooting out the side of it. And
yeah,
it's unmistakable.
And it's the same fuel, is that right?
Yeah, they both use the same hypergolic fuels, I believe. They use I forget what it was right now. So I think it was monomethyl hydrazine. I think I don't remember at the top of my head. It's getting late now, and and stuff. But you can look that up.
Okay, right. So here we have.
I had written the chemical equation on my Facebook, but the exhaust is the CO2, N2, and H2O, right? So of course the CO2 and the N2 you won't see, but the H2O means you're seeing steam. So the exhaust is a blast of steam, right? So that's what you would expect to see, and that's what we're seeing on the Soyuz. So why don't we see it on the Apollo? And there should be, and this is just a tiny little blast, right? The correction blast, right? To correct their position. So it's a tiny little blast, and you get this huge thing of steam. But if you're actually taking off from the surface, there would be tons of steam just billowing out of the bottom, right? So the NASA excuse is that, oh, because since the moon doesn't have an atmosphere, the steam is just dissipating so quickly. So then why would the steam not dissipate with the ISS? Right?
Yeah.
It doesn't. And that whole thing also, that same debate about why there's no steam on the liftoff, it also comes back to this, why there's no crater on the landing crater. And it's the same excuse. They say, oh, because the steam just dissipates, right? So I think that, you know, the debunkers like to make fun of us for saying, oh, you're saying there's no landing crater, and it's obvious why. But I don't think that issue goes away so easily, you know, because their whole excuse is this steam dissipation thing, and so it doesn't work. You know, here's a clear proof that the steam is not just disappearing. You know, there's just with a tiny blast you can see tons of steam. Yeah.
So even von Braun and the other scientists were all anticipating a blast crater, you know, buried underneath the dug underneath the lunar module and stuff, and suddenly there's no crater.
Yeah. It doesn't work out because the gas will still have a mass, so it still create a crater, whether it's dissipating or not. It's directed. That's the whole point of thrusters, isn't it? They're directed.
Right.
Yeah.
You get a drink.
It has the power to rise to lift that rocket up above the surface against the gravity. So therefore, as we discussed earlier with Newton's third law, there's going to be an equal and opposite reaction downwards in the opposite direction towards the surface of the moon. And indeed, even you hear them saying it, we're kicking up some dust.
Yes.
So this is just you know, this is the most iconic, right? The most iconic picture of them all, which I call the man standing under a spotlight. And so, you know, it's so clear, you know, I can't imagine how many people looked at this photo ever since the 1969 and not realize that this is a man standing under a spotlight, right? And so, of course, they photoshopped it later and they filled in all the background, you know, so you don't see the spotlight anymore. But
well, the official explanation. The official explanation is that it's simply to do with the angular reflection on the uneven surface, like you sometimes get on a beach. I mean, I've never noticed an effect like that on the Earth myself.
I've never heard that one. The explanation that I heard was that the conspiracy theorists, were the ones who edited it. That was the excuse I actually tracked down the original West Australian. You can look at my Moonfaker series. There's one called Posing for Portraits, which I actually tracked down the original Buzz Aldrin photo. We made the front page of the West Australian, and you can see that same uneven lighting is there. So did we invent the time machine too or something?
Oh, that was the next thing they come up with.
I was just writing about that in the book, and I also found the New York Times as well, the same photograph on the same day, showing all the fall off.
Okay, this looks like the Earth from space.
Yeah, so this is just this is a very early weather satellite which was taking a photo of the Earth, and here it's very, very clear to see the Photoshop work on the edge of the Earth. I mean, this is the magic wand tool where you just, and then you can just cut away, and it leaves these little zigzags where they cut it. So this is a very clear. So I think that there's some times where they purposely try to remove the stars in order to maintain consistency with the Apollo photos.
Ah.
I think this is going to become an increasing problem in space exploration in the next few years. In that they're going to have to start looking at consistency. I mean, it's basically what Marcus's the articles in Nexus by Phil Coots have said, because people are going to say, well, how, like, you get a different effect with modern missions than you got back then, and they're going to say, well, why is that? And they had the choices either to come clean or to edit and fake modern missions in some way or another to a greater or lesser degree, just to fit in with the to sort of like to retrofit it with the Apollo story.
They're going to have a problem with a feedback loop with this, because the more lies they create, the more lies they're going to have to cover.
They're painting themselves into a big corner, aren't they? Yeah.
Yeah.
Okay. So what we seeing here?
Okay, so this is so just the last week I downloaded 9,000 of these thumbnail images, and so what happened is what I think what happened is when they made these thumbnail images a long time ago, before they started photoshopping the high res stuff. So here I just got two examples of the thumbnail compared to the high res. So when you download the high res, you can see it's very clearly been photoshopped compared to the original image, you know, because they've upgraded all the high res images, but when you look at the thumbnails, they haven't upgraded all their thumbnails yet. So you can actually see the silhouetting or the spotlight effect more in the thumbnail images.
They wouldn't be bothered doing those because they just want you to look at the bigger pictures, I suppose.
Right. So this is just this is coming to the this was the 1983. This was the first time, in my opinion, this is the first time that they used this PLIS life support. Okay, because you know, before Apollo, all of the spacewalks had an umbilical cord, right? Yeah. And then supposedly during Apollo, the PLIS was ready. You know, we can go spacewalking with this backpack now, and we don't need an umbilical. But I don't think the PLIS was ready in 1969. But this in 1983, I think they had the PLIS ready. So this is, in my opinion, the first time that the PLIS was ready for a spacewalk.
That's the backpack that the astronaut is wearing in that image. It's
right.
Because you see the same. Yeah, you see the same thing in the a very similar kind of spacesuit in the astronauts on the Apollo missions. But what we've discussed on previous shows about how the PLIS, the backpack, wouldn't be able to do the job.
Somebody in my group found this glitch, and I forget his name. I could probably look it up, but it was just so incredible, you know, to see that so that is he asked me, what is it? That's a docking radar, the radar which is supposedly helping them to dock with the other ship, and it just falls when it trips over the there's something that's holding it up, and then when it turns it just falls and it droops in the gravity. Right. So this is like a smoking gun, and I can't believe that they didn't try to edit that out or something, or they should have reshot the scene or something. But somebody left that in there, in my opinion, as a smoking gun, because this is like, and so the guy who found this, I think he put it on his YouTube channel, and then he got a lot of NASA people criticizing him, saying, "Oh, you did that. You did the video editing. You made it look like it's falling, but it's not. This comes directly from the NASA, and it's not only from the NASA webpage, but also the NASA did a documentary about Apollo 11, and that clip is on the documentary, right? And it falls exactly the same way. So they can't even edit it because now it's permanently part of that documentary, right?
Yeah. The idea that that some of the mistakes are so obvious that they were done deliberately by people who wanted to maybe get the word out. I mean, this is a core thesis of Bennett and Percy's book, Dark Moon, Apollo and the Whistleblowers. It's Perfectly possible. I mean, obviously, I think that's perfectly feasible. On the other hand, it could just be the filmmakers they used, didn't come from the David Lean school, and they didn't maybe have a big enough crew to include continuity errors and editors and all the people that a normal movie production would have. So that's also quite possible, I think. Either way, they must have been very confident of their ability to fool people, just to wow people with the fancy pictures of astronauts bouncing around, so they wouldn't notice these little anomalies.
I think
Obviously,
even
years later, we're not so emotional about it. We can.
I was just going to say, I think some of the astronauts themselves have even made a little tips of the hat in that regard, because I remember in Apollo 8, I think it was Lavelle who said this instead. He says, the moon looks like plaster of Paris.
Yes.
Orbiting around it and stuff.
I mean, Neil Armstrong, even in one of his first speeches on the moon, he gives tribute to the backroom boys, meaning the set makers, the floor managers.
Yeah.
But couldn't it be just pure arrogance? They think that they've fooled you so much. Look at the COVID thing. Look at 9/11, where they just get lazy. They think, well, we fooled you already. You're stupid enough to believe this. You're not going to look into the details.
Yeah, it could well be, Colin. Not only that, it may even be. I mean, if you go along with the idea that a lot of these people I know this is not all of you will go along with me on this, but are involved in, say, Freemasonry and things like that. There's almost like a kind of belief system whereby it's almost like a karmic thing. They can tell us what they're doing and make it so obvious we have to see it, and then essentially the burden is on us to react, and if we don't, in a sense, it's kind of our fault according to their belief systems.
A lot of these things I didn't find, I just other people found, but some of them I did find myself. And like for example, one time several years ago when I was looking through the videos, and I saw that famous scene where he jumps up to the ladder and he misses the ladder and he's dangling by a wire. And I thought, okay, that's something that was original. I discovered that, but then later I saw that on American Moon, so I was like, okay, that's cool. But when I first discovered that, my first impression was, okay, this is like a long video. It's several hours long, and they didn't want to just do the whole retake just because of one little blunder like that.
It's also possible they were on where they had time constraints, probably not budgetary, but time constraints and things like that. They probably thought, we don't have time to go and reshoot. We just have to put that in there and hope for the best, hope nobody notices.